Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. In this session, we will discuss about the interrupts and interrupt cycle of 8086 microprocessor. So before going to the detailed discussion about the interrupt cycle and the classification of interrupts, first we need to know what is meant by interrupt. Here, the process of interrupting the normal execution of the program to carry out the specific task is called as an interrupt. So generally, interrupt is an external event that will come in between when executing the main program. So that is why we will say it is an interrupting process during execution of the program. So here, generally, interrupt is nothing but it consists of set of instructions. That means interrupt is also a small program which we are writing separately in order to perform specific task. Here, interrupt within interrupt is called nested interrupt. So for example, when the processor is executing the main program, so main program will consist of some set of instructions. When the processor is executing the main program, as we know, the program will be executed by the microprocessor in the sequential order. When the main program is executing, if any interrupt comes in between, what it will do? The microprocessor will store the contents on the stack up to where it has stopped, and then it is going to branch the control to the ISR. So ISR means it is a small program which we are writing separately in order to perform a specific task, and it also consists of some set of instructions. So at the end of interrupt program, we have to write an instruction IARE. When this IARE instruction is executed by 8086 microprocessor, again the processor is going to pop the contents from the stack, and using that contents, the control will be moving to the location where it has stopped previously. And from there, the program starts continuing again. Now, there is no rule that only interrupt should come during the main program. So, there is also possibility of coming the interrupt during execution of this interrupt service routine. So generally in the first case, when interrupt has occurred, the control has branched to the interrupt service routine. When the processor is executing this interrupt service routine, again, if there is any interrupt coming in between, again, the control is going to stop executing the instructions in the main program, and then again it is going to branch to the interrupt service routine. And again it is going to execute the interrupt service routine. At the end of this interrupt service routine, here also we have to write IARE instruction. When this IARE instruction is executed by the 8086 microprocessor, again the control will be going to the main program where it has stopped, that is ISR, and it is going to complete this ISR. When the IARE instruction is again seen by the processor during executing the interrupt service routine, again the control will be going to the main program, and then it executes the main program until last instruction is executed. So here this is an interrupt. Interrupt has been generated in the ISR also. So in this case, we call it as interrupt within interrupt. This case is called nested interrupt. Now, here interrupt service routine. So what is meant by interrupt service routine? So we can also call this interrupt service routine as subroutine or procedure. Okay. So here interrupt service routine is a small program which consists of some set of lines, and it will be executed generally when interrupt arises. Okay. So for example, if the processor is executing the main program, okay, so main program will consist of some set of instructions, and as we know, the processor will execute the instructions in the sequential order. When the processor is executing the main program, if there is any interrupt coming in between, if there is any interrupt arises, so this interrupt may be due to software or due to hardware. Okay. So if any interrupt due to hardware means because of some external devices, or due to software means because of some special instructions that we have used in the program. So here if any interrupt comes in between, the processor is going to store the contents on the stack after incrementing the instruction pointer by 1. Then the control will be branching to the ISR. Okay. So ISR represents here interrupt service routine. Interrupt service routine is also a small program which consists of some set of lines required to perform a specific task. Compulsory, when the processor is executing the ISR, if we are writing the program as an interrupt service routine, we have to end that ISR program by writing the instruction called IARE. Okay. So when this IARE instruction is executed by the microprocessor, then only the control will be again moving to the main program from where it has stopped. From there, it starts executing again. And the main program will be executed until the last instruction is completed. Now, so in order to define this interrupt service routine, so while the CPU is executing the program, that is main program, so here generally CPU, in this case, it is nothing but a microprocessor. Okay. So when the microprocessor is executing the program, if any interrupt comes while executing the main program, that particular interrupt breaks the normal sequence of the execution of instructions. Then it is going to divert its execution to some other program. That program generally we call as interrupt service routine. It can be simply represented as ISR. We can also call it as subroutine. So after executing that ISR, the control will be again transferred to the main program. When this IARE instruction is executed in the ISR, again the control will be branching to the main program. After that, it will be again executing from where it has stopped the main program till end of the program. This is the definition of the interrupt service routine. And next one is here, generally when we call that the processor is having multiple interrupt handling capability means, if that particular device, that means whenever a number of devices interrupt a CPU at a time, and if the processor is able to handle that interrupts properly, then we call that it is having multiple interrupt handling capability. So generally here, when the number of devices interrupts a CPU means, if more number of interrupts are coming at a time to the CPU, how the CPU is going to, that means microprocessor. Here CPU is nothing but microprocessor. If more number of interrupts comes to the microprocessor at the same time, in that case, how the microprocessor is going to handle that interrupts? If the microprocessor is handling the multiple interrupts, then we call that it is having multiple interrupt handling capability. Okay. So as we know that generally, if you consider 8086 microprocessor, we have two interrupt signals. only 2 interrupt pins are there related to interrupts in 8086 microprocessor. So the 2 signals are, one is INTR, another one is NMI. So here generally this INTR represents interrupt, request, and this NMI represents non-maskable interrupt. Okay. So from any of these pins only, the interrupts will be coming, external interrupts will be coming to 8086 microprocessor. So since here there are only 2 pins related to the interrupts in 8086 microprocessor, only 2 interrupts can come to 8086 microprocessor. Okay. So for example, if more than 2 interrupts, if 8086 microprocessor wants to handle more than 2 interrupts, then we have to go for a controller which is called PIC. Its IC number is 8259. Okay. So PIC represents programmable interrupt controller. So in order to handle more than 2 interrupts, 8086 has to go for this programmable interrupt controller in order to access more number of interrupts. Why? Because here this programmable interrupt controller is an IC which is having interrupt pins. Okay. So how many interrupt pins this programmable interrupt controller 8259 IC is having means, that is from IR0 to IR7. Okay. So IR0 to IR7 means IR represents interrupt request 0, interrupt request 1, interrupt request 2, so on up to interrupt request 7. That means totally 8 interrupt request signals are available. So each interrupt request pin is capable of handling 1 interrupt. So since there are 8 interrupt pins, 8 interrupt devices can be handled by one 8259 IC. So for example, if more than 8 interrupts, if it want to handle more than 8 interrupts, then we have to go for connecting this 8259 ICs. For example, in case of handling more than 8 interrupts, we have to go for using this programmable interrupt controller in master-slave configuration. Master-slave configuration. So in this configuration, what we are going to do means, we are going to connect this master and slave 8259 IC in the cascading manner. So if we are going to connect that, each IR0, each interrupter signal of master IC is capable of handling one slave 8259 ICs. So for the master 8259 ICs, like here, if you consider this is one 8259, which you are considering it as a master. So if it consists of IR0, IR1, so on up to IR7 interrupt signals. So if you are going to connect this 8259s in the master slave configuration, for this each interrupt request line, one 8259 IC can be connected. This 8259 IC, we can call it as a slave IC. And again for this IR1 also similarly, one 8259 IC can be connected. This is a slave 8259 IC. So similarly, like that, here for IR7 also, you can connect 8259 IC, slave IC. Now, for each 8259 IC, again, it consists of interrupt request lines from IR0 to IR7. Okay. So similarly, for slave 2, you will have IR0 to IR7. Similarly, for the last 8259 IC, IR0 to IR7. So totally here 8 slave ICs. It is nothing but PICs can be connected. Each PIC is having 8 interrupt lines. So 8 into 8, 64. Okay. So 64 IO devices can be handled. So if you are going for connecting this programmable interrupt controller in master slave configuration, then more number of interrupts handling capability will be there. Okay, interrupt handling capability will be increased. So this 8086 have to take help of this 8259 programmable interrupt controller IC in order to handle multiple number of interrupts, such that we can say that 8086 microprocessor is having multiple interrupt handling capability. Now, so here processor, that means 8086 microprocessor, can be interrupted in different ways. So what are the different sources that will be generating the interrupts means? Okay, so one may be because of some peripheral devices. Peripheral devices means IO devices here, external devices. Okay, so the peripheral devices, what are the peripheral devices that you can take is, for example, we can have here keyboard, or because of some any devices connected to the serial ports. Okay, so here printer. All these are some devices that will be generating the interrupts. Okay, so we can call that the interrupts are generated by the peripheral devices. And interrupts may also happen because of some special instructions in the program. So for example, special instruction INT, interrupt. INT instruction is called a special instruction. So if this instruction, if we are using while writing an assembly language program, if we are using this INT instruction, if that is executed by 8086 microprocessor, then we can say that interrupt is generated by special instruction in the program. So this INT represent interrupt generally. It may be either interrupt 0 or it may be INT 1. Okay, so generally any type of interrupt may be. So in 8086 microprocessor, in the interrupt vector table, totally here 256 interrupts are there. Okay, so those are the interrupts from INT 0 to INT 255. So if any of these interrupts are executed, then we can say that it is an interrupt because of some special instruction in the program. And the third case is, interrupt may also happen because of some exemptional condition in the program. So here some of the exemptional conditions we can take, like divide error. Okay, so in case of divide errors and all, we can call them as the interrupts that are generated because of some exemptional conditions. Like for example, during division operation, you have to select the value of dividend and divisor. Okay, so for example, if the value of divisor is too small compared to the dividend, okay, so if the division operation is performed, the result will be large. That means the quotient value what you are getting will be large. Okay, it is not able to fit in the registers. In such cases, we call the interrupt that is has been generated by the exemptional condition. So these are the basic sources that will be generating the interrupts. And next one is, here data transferring between the processor and IO devices will happen because of two methods. Okay, so what are the two methods here means? One is polling method, another one is interrupt method. Here basically, though there are two methods which will be data transferring between processor and IO devices, though there are two methods, out of these two methods, this interrupt method is preferred. This interrupt method is preferred. Okay. Compared to the polling method, the interrupt method is preferred because there is a small drawback in the polling method. And selecting this interrupt method leads to some advantages. Now we will see how the data transfer will be performed in the polling method and interrupt method. Now, so first let us discuss about the polling method. So here in the polling method, what happens means the microprocessor continuously monitors the status of the given device. When the status condition is met, then only it is going to perform the service. After that, it moves on to the next device until each one is serviced. So for example, if you see here, this is the example for polling method. And if you see this example, we can clearly understand why the polling method is not preferred for data transfer between I/O devices and processor. Here the best example of the polling method is constantly keep on opening the door to check whether anybody has come. Like this, suppose if there is no bell ring at the door also, the person inside the house will be keep on opening and closing the door and checking whether any person has come or not without ringing the bell. So what happens means, though there is no bell ring, the person is continuously going on and opening the door and closing the door and checking whether any person has come or not. So in this case, the drawback is waste of time. Instead of doing like that, when only the bell ring, the person inside the house can go and open the door and see what has happened. That is what happening in the interrupt method. But whereas in the polling method, that is the drawback actually. So in the polling method, the microprocessor continuously monitors the status of the given device. It is not going to do anything. Though there is no interrupt occurrence, it keeps on monitoring the status of the given device. During that monitoring process, continuous monitoring process, if the condition is met, that means if any interrupt has come, then only it is going to perform the service. After that, it moves on to the next device until each one is serviced. So this is the main drawback, waste of time in the polling method. But here, coming to the second method of data transfer between I/O devices and memory, the second method is here, interrupt method. So generally this interrupt method is preferred compared to polling method for data transfer. So what is the importance of this interrupt method means? In the interrupt method, whenever any device needs service from the microprocessor, what that device will do? The device notifies to the processor by sending a signal. That signal generally is called as interrupt request signal. It will send that signal. Okay. So upon receiving the interrupt signal, what the microprocessor is going to do means, after receiving that interrupt request signal, the microprocessor holds, that means stops whatever it is doing, and it is going to service the corresponding device. That means it is going to give service for the requested device. Okay. Now, so if you see the same example for the interrupt method, the example is here, let the bell ring, then open the door and check who has come. The processor will be doing its own work. That means the processor will be executing the main program. Okay. So whenever the interrupt comes through interrupt request signal only, the processor holds whatever it is doing and then it is going to service that interrupt. Okay. So the person inside the house will be doing his own work. Whenever the bell ring only, they will go open the door and see who has come and service them. Okay. So this is the main advantage of the interrupt method. Efficient utilization of a microprocessor. So out of this polling method and interrupt method, since there is a small drawback in the polling method, this interrupt method is preferred for data transfer. Now, classification of interrupts. So here, interrupts are classified into different types. So here the first classification is hardware and software interrupts, and the next one is vectored and non-vectored interrupts, and the next classification is maskable and non-maskable interrupts. So we will discuss in detail about this classification. So the first one is about hardware and software interrupts. Now, so coming to the hardware interrupts, the name itself says hardware interrupts. So hardware interrupts are nothing but the interrupts that are coming through the 2 pins of 8086 microprocessor. Okay, so here there are 2 pins, INTR and NMI. These are the 2 pins that are present in 8086 microprocessor, which will be handling the interrupts that are coming externally. So that is why these hardware interrupts are also called external interrupts. So the interrupts initiated by the external hardware by sending an appropriate signal to the interrupt pin of processor, it is called hardware interrupts. So these are the hardware interrupts that are generated by the external devices, what we call as IO devices or peripherals. So if there is any IO device connected to INTR pin of 8086 or NMI pin of 8086, we call that it is a hardware interrupt. See here. So that interrupt may be through INTR pin or NMI pin. So here INTR represents interrupt request, and NMI represents non-maskable interrupt. And so this is the best example to clearly understand how the interrupt will be accepted by 8086 microprocessor. So here consider there is a interrupt coming through INTR signal of 8086 microprocessor. That particular interrupt will be accepted by 8086 microprocessor only when the interrupt flag bit is set. And in another case, consider the same interrupt is coming through INTR signal, and here that particular interrupt will be rejected. So why this interrupt is rejected means, in this case the interrupt flag is not set. That means, in order to summarize this, if any interrupt comes through INTR signal of 8086 microprocessor, it will be accepted only when the interrupt flag bit is set. In another case, if any external or if any peripheral device that is going to generate interrupt, if it is connected through NMI signal, that particular interrupt will be accepted by 8086 microprocessor independent of the interrupt flag. In that case, no need to set the interrupt flag if any interrupt is coming through NMI pin. That particular interrupt will be accepted by 8086 microprocessor. And software interrupts. So software interrupts means if any special instructions are executed by 8086 microprocessor in the program, that particular instructions will be generating the software interrupts. That is why the software interrupts are also called internal interrupts. So the software interrupts are the program instructions. These instructions are inserted at desired locations in the program. While running the program, if software interrupt instruction is executed, it is going to initiate the interrupt. So for example, consider INT instruction. If such type of instructions are executed, if you are writing INT instructions in the main program, and if that instructions are executed by 8086 microprocessor, that particular instructions will be generating the interrupts. So totally in 8086 microprocessor, there are 256 interrupts available. So what are the 256 interrupts means? from INT 0 to INT 255. So totally 256 interrupts are available. And here generally the software instruction will be represented as INT N. So this INT is an instruction, it is an opcode, and where this N represents the type number. Since here we are having 256 interrupts, that is why here the value of N will be varying from 0 to 255. Now, same software interrupts means it is because of some INT instruction. So general format is INTN. Okay. So here this INTN interrupt, software interrupt instruction, it is a 2-byte instruction. 2-byte instruction means this is 1 byte and this is another byte. It is a 2-byte instruction. So the first byte consists of opcode and the second byte consists of the type number. So the first byte, it consists of opcode, whereas the second byte provides the interrupt type number. So there are 256 interrupts available in 8086 microprocessor. Among these 256 interrupts, generally we are going to learn in detail about 5 interrupts that comes under dedicated interrupts classification in the interrupt vector table. So what are that 5 interrupts means? INT 00. So this INT is an opcode and this 0 represents the type number. So based on this type number only, the ISR address will be calculated. So the INT 00. So why these 5 interrupts what we are learning here are called dedicated operation means each interrupt is having its own operation. So one of the interrupt is INT 00. Its function is divide error. And the next interrupt is INT 01. Next interrupt is INT 02. Next INT 03. And the next interrupt is INT 04. So among these 256 interrupts, we are going to learn about these 5 interrupts in detail. So these 5 interrupts are called dedicated interrupts. So these 5 interrupts are called dedicated interrupts. So why they are called dedicated interrupts means each interrupt is having its own dedicated operation. So if we consider here INT 00, that particular interrupt dedicated operation is divide error. So if we consider INT 01, its dedicated operation is single step. If it is INT 02, its dedicated operation is NMI. INT 03, that particular interrupt dedicated operation is breakpoint, that is end of the program. And INT 04, its dedicated operation is signed number overflow. These are the 5 interrupts we are going to learn in detail, and we will learn how to calculate the ISR address. Now, so that is what about the first classification, that is hardware and software interrupts. Coming to the second classification, the second classification is here vectored and non-vector interrupts. Okay, so only simple word here, vectored means no need to provide any address. The control will be automatically branching to the specific address. That type of interrupts are called vector interrupts. So if it is vectored interrupts, if a program control automatically branches to the specific address when the interrupt signal is accepted by the processor. Automatically branching means no need to provide any address. To that particular specific address, the control will be automatically branching. Such type of interrupts are called vector interrupts. And coming to non-vectored interrupts, here this non-vectored interrupts means in order to execute that ISR, compulsory address should be provided. Okay. So in this case here, vector interrupts, no need to provide address, automatically it will be branching. But whereas in a non-vector, in order to branch to that particular location, compulsory address should be provided. So in non-vectored interrupts, the interrupting device should supply the address of the ISR in order to execute in response to the interrupt. That is the difference between this vectored and non-vectored interrupts. And next classification is maskable and non-maskable interrupts. Generally here, we have talked about the hardware interrupts, which can also be called as external interrupts. That particular external interrupts may occur through this NMI pin or INTR pin of 8086 microprocessor. Okay. So for example, if any interrupt is coming through this INTR signal of 8086 microprocessor, then it is called as maskable interrupt. If any interrupt is coming through this NMI signal, then that particular interrupt can be called as non-maskable interrupt. Okay. So here, maskable interrupt means the interrupt that maskable, the interrupt that can be disabled. Non-maskable interrupts means the interrupts that cannot be disabled. Now, so the interrupts which can be disabled are called maskable interrupts. So disabling the interrupts are nothing but no need to execute that particular interrupt. Okay. So that particular interrupts can be rejected, ignored. So which type of interrupts can be ignored? The interrupts that are coming through this INTR signal can be ignored. That is why the interrupts, if any interrupts coming through this INTR signal, then we call that interrupts as maskable interrupts. Because masking means ignoring. That particular interrupt will not be executed. So example, INTR pin of 8086 microprocessor. Now, non-maskable interrupt. So the pin name itself says NMI. So NMI represents non-maskable interrupt. So if any interrupt is coming through this NMI pin, that particular interrupt is called non-maskable interrupt. Non-maskable interrupt means the interrupt that cannot be disabled, the interrupt that cannot be ignored. That means if any interrupt is coming through this NMI pin, that particular interrupt cannot be ignored. Compulsory that particular interrupt should be accepted. So that is the main difference between this maskable and non-maskable interrupts. Here, for example, any interrupt comes through NMI pin of 8086 microprocessor, we call it as non-maskable interrupts. So this is the classification of interrupts in 8086 microprocessor. Okay. Now, next, coming to the interrupt cycle of 8086 microprocessor. So, interrupt cycle of 8086 microprocessor totally says how the interrupt is coming, when the interrupt comes, how the contents will be stored, what are all the contents that will be stored on the stack. After that, how the interrupt service routine will be executed. After executing, how the control is again coming to the main program in order to execute the remaining lines of the main program. So this entire process, generally, we call it as interrupt cycle of 8086 microprocessor. So this interrupt cycle of 8086 microprocessor will cover all these steps, how the procedure will be. Now, first step is when the CPU is executing an instruction in the main program, if any external interrupts comes through the NMI pin or INTR pin. So as I told you, the interrupt may be through NMI pin or INTR pin. Okay. So if the interrupt is through NMI pin, interrupt cycle will be different. If the interrupt is through INTR pin, some steps will be different in the interrupt cycle. Okay. So when the CPU is executing an instruction in the main program, suddenly if any external interrupt comes through any of these pins of 8086 microprocessor, what happens means the microprocessor will first complete the instruction, whatever it is executing. After completing that particular instruction, then it is going to increment the IP. IP means instruction pointer. After executing that particular current instruction, the value of IP will be incremented by 1. So what happens if the value of IP is incremented by 1? It will hold the address of the next instruction that is going to be executed. After incrementing the value of IP, then the CPU is going to send the interrupt acknowledgement signal through NMI pin. So I told you, if the interrupt comes through NMI pin, it is going to send the interrupt acknowledgement signal. It is not going to check the status of the interrupt flag, because if any interrupt is coming through NMI pin, suddenly it is going to send the interrupt acknowledgement signal. It is not going to check the interrupt flag bit. Why? Because NMI pin is independent of interrupt flag bit. In another case, if the interrupt is coming through this INTR signal, it is not going to send the interrupt acknowledgement signal. First, if any interrupt comes through INTR signal, first it check the status of the interrupt flag bit. The interrupt flag bit may be set or the interrupt flag may not be set. If it observes that the interrupt flag is set, then only it is going to send the interrupt acknowledgement signal. For example, if it observes that the interrupt flag bit is not set, that particular interrupt will be ignored. It is not going to send the interrupt acknowledgement signal. Okay. So if it is through INTR, after checking the status of the interrupt flag only, it is going to send the interrupt acknowledgement signal. If the interrupt signal is through NMI pin, irrespective of the interrupt flag, it is going to send the interrupt acknowledgement signal. Now, after that means after sending the interrupt acknowledgement signal in any of the case, then the CPU is going to calculate the vector address. Sometimes the vector address may also be calculated because of the programmable interrupt controller IC also. Now, so after calculating the interrupt vector address, the contents of CS, IP and PSW. So CS represents code segment and IP represents instruction pointer, and this PSW is flag status, flag register. So the contents of all these three related to the main program will be stored on the stack. So the contents of CS, IP, PSW now points to the address of the next instruction of the main program from which the execution is to be continued after executing ISR. Now, so here after it is after completing the executing ISR, then what it is going to do means then the IF and TF are cleared. IF means interrupt flag, which says the status of the interrupt, and TF represents the trap flag, which represents the single step execution. So after executing the ISR, the interrupt flag and trap flag bits will be cleared. Then it is going to execute the ISR. After that, while executing the ISR, I told you already, the last step of the interrupt service routine, the last instruction should be IRET. So when this IRET is executed, again the control will be popping the contents of CS and IP from the stack, and then it again goes to the main program and execute the remaining instructions of the main program from where it has stopped. From there it starts executing all the lines in the main program. So that is the interrupt cycle of 8086 microprocessor. So in order to discuss about the same interrupt cycle of 8086 microprocessor in the diagrammatical manner, whatever the steps we have discussed previously, interrupt cycle of 8086, like first here consider this is the main program. So when the CPU is executing the main program, if any interrupt comes in between, what the microprocessor will do? The microprocessor will stop executing the main program. It is going to increment the value of IP by 1 in order to store the next address, and it stops executing the main program, and it is going to branch the control to the ISR. So before branching the control to the ISR, what it is going to do means it is going to push flag register. So that flag register is nothing but PSW. Okay, so it is going to push the flag register, push CS and IP. So these two contents will be pushed onto the stack. So when these contents are pushed onto the stack, here clear the value of IF and TF, because for the next instruction after executing the ISR. So after storing all these contents on the stack, then only that particular ISR will be executed. Interrupt service routine. Okay, so ISR represents interrupt service routine. This particular interrupt service routine will be executed. So this interrupt service routine also consists of some set of lines. The last instruction of the ISR should be IRET. So IRET represents interrupt return. When the processor executes this IRET instruction in the ISR program, then again the control from this subroutine will be branching to the main program. So before branching to the main program, it has to pop the contents from the stack. That means before the control is transferring to the main program, it is going to pop the contents of IP and CS from the stack. So not only this IP and CS, it is also going to pop the contents of flag register, which is nothing but here PSW. So these contents will be popped from the stack, and then the control will be again going to the main program where it has stopped, and from there again the main program will be continued. Okay. So this is the entire concept of diagrammatical representation of interrupt cycle of 8086 microprocessor. Okay. So this is what about interrupt, classification of interrupts, and interrupt cycle of 8086 microprocessor. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.